Sino ba? Di ba pinagdala ko rin na?
Sila sa bahay.
Sa bahay. Dala kayo na para makatakpan. Okay, this is where we, I think, stopped last time. Sa types na work. Diba? Wherein the last two types actually deals with what? Changes in the, rather than the macroscopic forms of energy, these two types of work deals with changes in what? In the internal energy or the microscopic forms of energy. So again, when we talk about internal energy, we deal with what? With the particles within the system, no? Rather than the system as a whole. And last time also, we have stated that expansion work here is the type of work that we're going to be considering for most of the cases. Because of what again? Because this is a typical setup that is easy to understand, especially in terms of what? Changes in the static forms of energy. And if you may remember, the temperature, pressure, and volume of the system here is the one directly related to what again? Directly related to the static forms of energy. Diba? Ano ba yung mga static forms of energy nga ulit na? We have macroscopic forms and the microscopic forms. So sa microscopic forms, we have the kinetic energy of the particles and the potential energy of the particles. The KE of the particles is the one directly related to the what? Temperature. Whereas the potential energy of the particles, molecules, atoms, or even the subatomic particles, they are related naman saan sa pressure. Diba? However, for most of the cases then, we're going to be dealing with ideal gas. So what's the difference between a real gas and an ideal gas? Okay, for a real gas, when you try to compress them, what will happen to the distance among the particles? They'll become closer together, right? And when they're closer, there will be interaction among them, and likely that they will form a liquid phase. Compressing them even more, okay, that means increasing the pressure, right? Or increasing the pressure even more, eventually the liquid phase will turn into what? Into a solid. Okay, so for a real gas, you consider the interaction among the particles such that you will form chemical bonds. Do you understand? For an ideal gas, on the other hand, okay, you compress an ideal gas, even though they're closer together, you don't consider the interaction such that the final state is still what? Or the final phase is still a gas. They're just closer together, or closer to each other. But you don't consider the interaction, so you don't consider the change in phase. By compressing them more and more, again, it should supposed to what? To form a solid structure. But then again, because this is an ideal gas, diba? You just take note that they are much more closer at a much higher pressure. So that's the difference between ideal gas and a real gas. You follow? So if that's the case, then change in internal energy, pwede pala ako dito pumesto. Okay, narinig naman sa audio. The change in internal energy would be what? Changes in the, not in the potential energy, diba? Change lang saan? Sa kinetic energy ng molecules. Diba? Kasi we don't consider the change in phase. Diba? Ang change in phase, doon ka lang nag-form ng bonds, no? Or nag-break ng bonds. Doon lang magkakaroon sana ng change sa potential energy ng particle. But since we're considering an ideal gas, then change lang sa kinetic energy ng particles yung pwedeng transpire. Okay. So we also also consider the interaction of this system, no? Especially the gas inside the cylinder, the interaction with the surrounding. Whenever there is interaction, there arises the what? The dynamic forms of energy. Okay, and that means that we have a thermodynamic process. Depending on the interaction, okay, that will lead to a particular thermodynamic process, and we have four. Okay, we had a glimpse, no, of the first two, processes. What are those again? The isothermal and the isobaric process. We also, I think, tackled how in the molecular level, these thermodynamic processes occur. Tama ba? Na-cover ba natin yan? We had the flavor, of how these processes, no, transpire in the molecular level. Okay? Ganun yun. Okay, so we have here the first two processes, isothermal and isobaric process. In an isothermal process, the temperature of the system must be what? Maintained, as you can see here. And what is again the requirement for us to have an isothermal process? The delta T, or the difference in temperature between the surrounding and the system should be very small, or infinitesimal. Infinitesimal, sobrang liit. Sige. So if this is my system again, let's draw the piston cylinder setup from which you have an ideal gas. As the system with T1, V1, and P1. The temperature, volume, and pressure again tells us about the energy it contains, the static forms of energy. Okay, and in particular, we're only actually referring to what? The internal energy. That is what? The kinetic energy of the molecules, because this is an ideal gas. Now, for us to have a thermodynamic process, there must be an interaction between the system and the surrounding. So let's say this is your surrounding, and the surrounding is what? Capable of transferring heat to your system. Because again, there's a difference in temperature. Only that the difference is what? Small. Maliit lang. If the temperature difference is small, ang ibig sabihin, magkakaroon pa rin ng heat transfer. Nga lang, yung magnitude ng heat transferred is only small also. I think you would agree na malaki yung delta T or yung temperature difference. Mas malaki yung heat na matatransfer. Mas malaki yung magnitude ng heat na matatransfer. So, again, what happens in the molecular level during an isothermal expansion? By the way, this is an isothermal expansion because for the gas to expand, kailangan mag-absorb ng heat. Okay? So, in the molecular level, upon transferring heat to the system, what will happen to the temperature at that instant? At that instant, it will increase, diba? So, ibig sabihin, the kinetic energy of the molecules will increase. But that increase, diba? Since the particles will move faster, they will move more, it will collide more doon sa walls ng piston. And the piston will move. Eventually, all the increase in kinetic energy of the molecules will be used up to move the piston. And at that instant ano na ang temperature natin? It will go back to its original temperature. So in that case, diba, nakikita nyo na may maintain yung temperature because all the increase in kinetic energy or increase in temperature, okay, are being used to move the piston. There is enough time for what? For the piston to move. Kasi mabagal lang yung heat transfer. And so, as you can see here, after an expansion, you also know that these are the final states already. The temperature was maintained. Of course, what happens to the volume? It increases, di ba? Nag-move yung piston eh. Di ba? After mag-increase yung temperature, na-transfer yung energy dun sa piston, nag-move. Bumalik sa original temperature. Kung bumalik din sa original temperature, meron uling temperature difference between the surrounding and the system. Magkakaroon uli ng heat transfer. Tataas uli ang kinetic energy ng molecules, gagamitin uli to move the piston. Lalaki uli yung volume. Diba? Pabalik uli sa original temperature. Magkakaroon uli ng heat transfer hanggang sa ma-reach yung limit dito, no? Cylinder. Move na. Ibig sabihin, meron ka ng panibagong volume dito. Yung pressure din bago, pero yung temperature mo, although designated as T2, is the same as your T1. Ba't na yung kumakan? Sa labas ba yun?
Sa labas po sa...
Okay. Now, what happens to the pressure here? The pressure decrease. Bakit bumaba yung pressure? Again, in the molecular level, because the volume is now much bigger, diba? Since pressure has something to do with what? Has something to do with the degree of collision of particles with the walls. And since malaki na yung volume, malayo na yung ita-travel ng particles, no? To collide with the walls of the cylinder and yung wall mismo ng piston. So, bababa yung rate of collision. The pressure must decrease. Understand? Kung yung speed sana ng molecule, kahit malaki yung volume, no? Kung yung speed ay bumilis, pwede sanang ma-maintain yung pressure, di ba? Pero hindi eh. Ganun pa rin kabilis yung speed ng molecules. Kasi hindi naman nagbago yung KE. The temperature was being maintained. You understand? Now, for the case of an isobaric process, expansion ulit tayo. And for it to expand, there must be again heat transfer from the surroundings. Although, the difference would be, the temperature difference between the surrounding and the system is much higher. Way much higher. Diba? So if there's a big difference in temperature between the surrounding and the system, what will be the corresponding heat transfer? It will be fast, higher in magnitude. Diba? Sabi natin last time, what will happen at that instant na magkaroon ng heat transfer for an isobaric expansion? What will happen? At that instant, the temperature will rise, diba? Much higher than the temperature rise for an isothermal expansion, right? And again, the increase in kinetic energy will be used to what? To move the piston. However, nahuhuli yung alin, yung pag-move ng piston, di ba? Compared dun sa heat transfer. The piston does not have enough what? Time, di ba? To have the energy transfer coming from the increase in kinetic energy of the particles. Ang bilis ng heat transfer mo, yung piston mo, well, mas mabilis yung movement niya compared sa isothermal. Pero compared dun sa rate ng heat transfer, di ba? Hindi lahat at each moment nagagamit to what? To move the piston. Kaya nga, once ma-reach yung limit dito, ano nangyari sa volume? Tumaas. Yung temperature ng system mo, mataas pa din. Kasi hindi lahat nagamit, di ba? To move the piston. Do you understand? So the final state here, well, the volume increases, the temperature was not maintained because of the fast process. I think we had terms here that describes these two processes. What are those terms? Reversible and irreversible process. The one that is reversible is what? The isothermal process. The irreversible process is isobaric. Okay, so maybe we'll talk about more of those terms later. Why is it called reversible and irreversible for the two processes respectively? Okay. So going back to your isobaric expansion, the volume increases, the temperature increases because of the fast heat transfer. What happens to the pressure? It was maintained. Why is that again? Because even though the volume has increased, diba? Yung pressure natin, bakit hindi bumaba? Kasi nung nag-increase yung volume, although malayo yung ita-travel ng particles natin, mas mabilis naman siya because of the increase in temperature. So nagkaroon ng compensation, di ba? Although malayo, pero mas mabilis siya. Ibig sabihin, likely na ma-retain yung rate of collision, maintaining the pressure. Follow? So what about for the compression part? An isothermal compression for what? Now take a look at the final states in terms of temperature, volume, and pressure. Siyempre, ang temperature maintained pa rin, di ba? But for the pressure and volume, it was just they were just the what? The opposite, di ba? For the expansion. So you're expecting na yung volume, siyempre, liliit. But how come na yung pressure tataas? We already know that na maliit ang volume natin, mas mataas ang pressure, di ba? Kasi yung rate of collision mas tataas because they're closer together. Understand? But how does really, okay, the temperature there was being maintained? That's the question. So, ano yung interaction na dapat mangyari with the surroundings? Kanina, heat yung sinupply, tama? Nag-move yung piston, nagkaroon ng tinatawag na na work. Dynamic form causes a change in the what? Static form of energy, diba? And there was also what? Another dynamic form that was generated, which is the work done. Understood? What about for compression? Paano magkakaroon ng compression? Pagka hinit mo ba, makakompress mo yan? Hindi. You have to apply work naman. So, kabaliktaran lang nito. Diba? Si surrounding naman yung mag-susupply na or mag-i-impose ng work doon sa system. So, pagka nag-impose na siya ng work doon sa system, an indirect change doon, yung volume liliit. Diba? Okay. Pag lumiit yung volume, what will happen to the temperature at that instant na kinompress mo siya? So we're not talking about the final state here. Pag-usapan muna natin yung during. Diba? So, kaya nga importante yung tinatawag na boundary conditions sa differential equations. Ito yun, ina-apply natin yung boundary conditions. Whether you're applying the initial and final or yung during. Okay? So, ang boundary condition natin muna is during the process. And at that instant na nag-apply ka ng work, lilit yung volume. Tama ba? Nung lumiit yung volume, ano mangyayari dun sa pressure at that instant? Tataas yung rate of collision. Tataas yung pressure. Tama? Ano mangyayari dun sa temperature or Ke ng particles? Tataas din. Diba? Pag mas nag-collide ng mga particles mo, diba? Mas tataas yung molecular activity. Diba? Yung kinetic energy thereby increases also at that instant. Okay. Now, nasaan tayo? Isothermal or isobaric? Isothermal muna tayo. Isothermal. So, same as the isothermal expansion, dapat dito yung work done, mabagal lang din. Kasi nga dito yung expansion dito, paunti-unti lang. Kasi yung heat transfer, paunti-unti lang din. So, babalik na rin mula, ang supply ng work dito, pakunti-kunti lang. At that instant na mag-supply ng counting work, volume will decrease, pressure increases, the temperature also increases. Now, since meron ng temperature increase dito, sige, meron ng temperature increase doon sa system because of what? The volume decrease. Okay. Meron naman yung temperature difference between what? The system and the surrounding. Sino mas mataas ang temperature? Si system. That difference in temperature will lead to what naman? Heat transfer. Ibig sabihin, yung increase in kinetic energy, di ba? Nailabas din. Because of the temperature difference now between the system and the surrounding, gagamitin yun to release the heat from the system. Do you understand? Now what will happen to the temperature? It will go back to its original temperature. Did you follow? That is how the temperature is being maintained in an isothermal compression. Compressed counter, volume decreases, temperature at that instant increases, there is now temperature difference between the system surrounding, heat transfer. And then, temperature goes back to its original value. Siyempre, until ma-reach mo yung final volume, halimbawa, dito tayo nag-start. Dito tayo nag-start. Ang T1, V1, and P1 muna, yung T2, V2, and P2. Iko-compress mo po, unti-unti until ma-reach to. Diba? Still, the temperature was maintained there. Ano nangyari sa volume? Siyempre, lumiit. After the process, no? Ito na yung terminal, for example. Ngayon, ano nangyari daw sa pressure? Tumaas. Bakit tumaas? Same pa rin yung speed ng molecules, di ba? Pero yung volume mas maliit na. O, mas pataas ang degree ng collision ng particles sa walls. Pressure decreases. Naintindihan ba si expansion and compression? Sometimes, you may realize sa problem solving, hindi siya tinatawag na isothermal heating. Yung expansion natin, heating to, diba? Nag-heat ka ng system. Why is that? Kasi, yung ibang reference, since hindi naman nagbabago yung temperature, it's as if hindi ka naman talaga nag-heat. Pero there are references na gumagamit pa rin ng term na isothermal heating. Kasi at that instant na nag-expand yung gas, nag-absorb pa rin siya, although na-maintain. Paano naman yung compression? Sa compression, di ba, yung heat lumalabas naman? Cooling naman ang tawag. Di ba? Isothermal cooling. Okay? So, any question for an isothermal process? Isobaric naman. Compression. We do the same thing. Si surrounding, ang mag-a-apply naman ng work. Pero yung pag-impose ng work, hindi dahan-dahan, no? Mabilis. Tama? So, once na mag-apply ka ng fast work, doon sa ideal gas natin, what will happen to the volume? Again, it will decrease. And what will happen to the temperature at that instant? What will happen to the temperature? Isobaric tayo, ha? Isobaric. What will happen to the temperature at that instant? Tataas, di ba? Now listen. Listen. Yung increase ng temperature dito, sobrang taas compared dun sa increase ng temperature doon sa isothermal compression, di ba? Kapag malaki yung difference ng temperature between the system and the surrounding, ibig sabihin yung amount or magnitude ng heat na lalabas, malaki din. Sa sobrang laki nung heat na nailabas, after the process, tingnan nyo, ano nangyari sa temperature? Lumiit. Diba? Nag-increase at that instant na nag-absorb ng energy because of the work done. But because there is a large difference in temperature, kasi hindi unti-unti yung ginawa, isang bagsak, di ba? Ang laki ng temperature difference between the system and the surrounding. And that leads to what? A high magnitude of heat released into the surrounding. So if there was a high magnitude of temperature release, what will happen to the temperature of the system? It will go down. Hindi katulad sa isothermal compression, di ba? Kada work, labas muna. Work, labas muna. Follow? Of course, the volume will what? Will decrease. Mali. Diba? Now, how was the pressure maintained? Paano na-maintain yung pressure? In the molecular level, again, we have to account what happens in the molecular level. Paano na-maintain yung pressure? Tingnan nyo ha. Di ba lumiit yung volume? Lumiit yung volume, tama? There should be, or there's supposed to be an increase in pressure because of the small volume. However, dahil yung temperature mo bumaba, mas mabagal na siya, di ba? So even though maliit yung volume, mas mabagal yung particles mo, ma-maintain yung rate of collision. You understand? Okay, I think you do understand the first two processes. The next two processes would be a lot more easier. And they're actually connected dun sa first two processes natin. Connected in such a way that still, we're going to be accounting for the changes in pressure, volume, temperature. Okay, bakit tayo pumunta dun sa last two processes? Bakit tinawag na reversible yung isothermal, the one that is slow, and irreversible yung isobaric? Kasi? Yeah.
Yung heat transfer, since work mo na and then heat transfer and then go back to normal, mas ano siya, na pwede siyang nag-reverse, bumabalik sa original position and original state.
So, tingnan nyo halimbawa, unahin natin isothermal expansion, nagkaroon ng isothermal expansion. Pwede mo bang maibalik sa original volume? Yes, pwede. Go-compress mo na. Ganun din naman si isobaric. After expansion, go-compress mo na to go back to the original volume. Literally, the two processes can be what? They can go back to their original state. Okay? Pero bakit reversible yung sa isothermal, yung sa isobaric tinatawag na irreversible? And the term irreversible, okay, kind of means what? Parang hindi maibabalik, no? But again, literally, you can what? You can just compress again the ideal gas in an isobaric setup, diba? And it will go back to its what? Original volume, original what? temperature, di ba? While maintaining the pressure. Why is that? Bakit irreversible yung tawag sa expert? Okay, I think the best way to explain that is that during an isobaric process, expansion in particular, what happens is that the temperature of the particles is increasing, right? Take note that the temperature, okay, of the ideal gas is increasing, diba? Kung dito yung heat transfer natin, there can be what? There can be losses of heat dito. Kung dito yung yung tawag dito yung focus, no? Yung part wherein may heat transfer. Pero paano dito sa mga parts na dito? Di ba merong temperature increase dito? What will be the temperature here? Hindi naman same yung temperature dito, tsaka dito. Kasi dito yung focus ng heat transfer. What I'm saying here is there can be what? Heat losses. Diba? So even though, literally, you can just compress it back to obtain the original volume, temperature, and pressure, but you already left, it has already left a mark, same mark yung heat loss doon sa surroundings mo. Nakuha? You get the notion? Whereas, for an isothermal process, di ba lahat ng heat na sinusupply, na-convert sa work? 100% conversion? No? So technically, and literally, di ba, pwede mo siyang ibalik. Kasi walang heat loss. Do you understand? And that's actually what? The notion, of why we're having losses of energy even sa heat engines natin. So car engines, bakit? Sobrang bilis kasi, di ba? Hindi naman pwedeng mabagal. No? At taasan mo yung efficiency conversion ng heat sa work. Di ba? Hindi naman kasi yung practical, di ba? So kailangan balance. Mabilis, pero somehow, mataas pa rin yung efficiency. Until now, nandun pa rin naman yung problem. Gusto natin mapataas yung efficiency ng conversion ng heat sa work, pero gusto rin natin mabilis yung andar ng sasakyan, di ba? So nandun lagi yung issue. Question? Okay, let's now proceed to the next two processes. Isopistic here is also kung nakikita sa video. So, ikakalat ko nga. Kasi makikita, nagsusulat ako sa pero binubura ko naman yan. Wala dito yung isochoric process, by the way. So isochoric, volume yung constant. Final states. Okay, take a look at this next process that we have here, isochoric process. Notice that instead of using the terms expansion and compression, what do you notice? I'm using heating and cooling. Why is that? Walang change na volume. So neither expansion nor compression will happen. Diba? So, ano yung counterpart ng heating? Expansion. Doon ka na susupply ng heat. Tama? So in an isoporic process, the piston can't move. I'm using the same setup here. Same schematic here. But if you understand the notion, kayo nang bahala mag-redraw, no, ng panibagong setup for each process. But in an isoporic process again, you just have to what? To lock the piston. Naka-lock. Such that when heat is transferred, what will happen to the temperature? Increase. So as the pressure. Diba? Kasi same yung volume mo, mas mabilis yung yung particles, mas tataas yung rate of collision. Hello? Paano naman yung cooling? Ang cooling natin is what? Ito yung boundary condition. Ang initial state ng cooling is yung final state ng heating. Ibig sabihin, di ba, nag-heating ka na, tumaas na yung temperature, tsaka pressure. Yun yung initial state mo naman for the cooling. Kasi eventually, di ba, mataas yung temperature ng system? Okay? Mataas yung temperature ng system, ibig sabihin, pag tinanggal mo na yung heating, dahil meron na ngayong temperature difference between the what? Between the system and the surroundings, di ba? Eventually, yung increase in kinetic energy na system mo, ilalabas na. Tandaan nyo, kung dito yung focus ng heating mo, di ba? Tatanggalin mo na yun kasi cooling na. Di ba nga tumaas yung temperature ng system? Yung temperature dito na surrounding, mas mababa. Even here, actually, kasi tinanggal mo na yung heating, di ba? Tinanggal mo na yung heating. Mas mababa na yung temperature dito. And again, eventually, the heat will be released. What will happen to the temperature? It will decrease. What will happen to the pressure? Siyempre, it will also decrease. Kasi mabagal na di ba? Yung rate of collision, ma-apektuhan din. Do you follow? Lang yung sa isoporic process. The important thing is dapat clear ka doon sa boundary conditions. Okay? Tinan nyo sa isobaric expansion. Ano nangyari sa isobaric expansion? Tumaas yung temperature, final state, di ba? Paano kung baguhin ko yung boundary condition? Ibig sabihin, sabi natin tumaas yung temperature sa isobaric expansion, right? Ibig sabihin, maghintay pa ako ng kaunting time. Di ba, i-release lahat yon sa surroundings? And eventually, what will happen to the temperature? Babalik sa dati. Hindi na isobaric yun. Do you follow? Hindi na ma-maintain yung pressure doon. Do you follow? So the boundary conditions are important. Pinutol natin, at that instant na na-reach niya yung limit ng piston, the temperature is still much higher. Okay? Adiabatic. For an adiabatic process, Q is equal to adiabatic expansion. Okay, we can say it happens. Set tayo ng boundary condition. Happens after isobaric expansion. Pag compression naman, boundary condition natin is happens after adiabatic expansion. Okay? So let's have another schematic here to explain, illustration to explain. Okay, so we have an adiabatic expansion first, and it says here that it happens after an isobaric expansion. Okay? Ano nga ulit nangyayari sa isobaric expansion? Nagkaroon ng transfer of heat muna. Diba? Then, nangyayari is, nag-move yung alin yung piston. So, kunin natin yung final state ng isobaric expansion dito. Ibig sabihin, meron pa siyang enough space for expansion. Pero i-cut natin. Okay? Dito sa state na to, ganun pa rin yung magiging final state natin. Yung volume tumaas, yung temperature mataas pa rin. Kuha? Final state ng ano to na isobaric expansion. Susunod natin yung alin? Adiabatic expansion. Pag sinabing adiabatic, maglalagay ka ng insulation doon sa surface ng cylinder. Pag may insulation, heat cannot escape. Diba? More heat can be absorbed. Do you understand? Okay? So, ito yung original state natin or initial state natin. The T2, V2, and P2 of an isobaric expansion. Yun yung initial state natin sa adiabatic expansion. Okay? So, para mag-proceed ng adiabatic expansion, ano daw gagawin mo? Lalagyan mo na ng insulation. Lagyan na tayo ng insulation. Makikita nyo lahat ng processes na to. I-recall nyo sa thermodynamic devices, heat engines, and what? Refrigerators. So you have to get the notion for each thermodynamic process. Now, take a look at this. Given the piston is what? Insulated. Hindi rin insulation. Kasi ito yung bago mag-isobaric expansion. Nasa yung insulation? Pati yung piston, di ba? Insulated na. Now, ano yung temperature natin dito? Mataas o mababa? Mataas, di ba? Compared dun sa T1. Ang ibig sabihin, yung kinetic energy ng particles natin at T2 is still high. Which means it is still, or they are still, the particles, capable of moving the piston. Do you understand? Until it reaches the limit here, until ma-reach tong final volume na to. Nakuha? Ibig sabihin, meron na akong T3, V3, and P3. Meron na akong T3 dito, V3, and P3. Kuha? Now, ano ngayon yung nangyari? Tumaas ba or lumiit yung mga thermodynamic properties natin? Ano nangyari? So, doon muna tayo sa, ano yung unahin natin? Sa volume. Mas obvious yun eh. Ano nangyari sa volume for an adiabatic expansion? Tumaas. Ano nangyari sa temperature? O sa pressure muna. Sige, ano nangyari sa pressure? Sige, if you're having hard time, temperature. Ano nangyari sa temperature? Since nagamit, di ba, yung kinetic energy ng molecules to move the piston, it will decrease. Okay. Now, what will happen to the pressure? Malaki na yung alin, yung volume mo, tapos bumaba pa yung temperature. Ano mangyayari sa pressure? Decrease yan, pressure. Malaki na, bumagal pa. Yung rate of collision, mas mababa. Kuha? Adiabatic expansion. Wala kang heat involved dito. Tama ba? Ano lang meron? Work lang. Kasi yung instant na nagkaroon ng expansion, wala nang heat na ita-transfer, di ba? Paano nagkaroon ng expansion? Kasi nga, mataas pa rin yung temperature after an isobaric expansion. Yun yung ginamit to further, di ba? Take a look at the boundary condition now. We're increasing the time frame, di ba? We're letting the ideal gas there expand more to reach a final volume, while the cylinder is insulated. Do you follow? And I think for the compression of an adiabatic process, it's much easier because it happens after the adiabatic. Sige. Ito yung ano mo. Ito yung magiging initial state mo. Yung volume mataas, temperature mababa, pressure mababa. Kapag nag-apply ka ng work doon sa system natin, anong mangyayari sa volume? Siyempre, bababa. Anong mangyayari sa temperature? Tataas yun. Diba? Kahit habaan mo yung time frame, hindi magre-release ng heat, diba? Kasi insulated. Tataas yung temperature, yes, at that instant. Pero kahit baguhin mo yung boundary condition, tagalan mo, maintain pa rin yung temperature. Why is that? Hindi magre-release ng heat. Why? Insulated yung container na. So if the temperature increases, since mabilis na siya, pressure, diba? Opposite lang naman eh. Okay? And again, the term heating and cooling are actually not used, especially kapag adiabatic expansion. Why is that? Kasi walang heat transfer naman na nangyayari. Merong energy transfer through work. Diba? So, although merong energy transfer din through work, meron bang adiabatic cooling? Because the cooling term has something to do with heating kasi, di ba? So since wala namang heat transfer palabas, again, some references omit the term cooling. Any question from the or thermodynamic processes? Later on, we're going to be applying the first law of thermodynamics equation dito sa mga processes na to. So, having understood the concepts for each process, you'll be able to apply appropriately the first law of thermodynamic equations. Question? Okay, next slide here. Something to do with the irreversible and reversible work process. You already know this. We now proceed to the first law of thermodynamics. By the way, your exam will be perhaps Thursday. Next week, Thursday. Kung hindi man, Thursday, Saturday. So, what about the first law of thermodynamics? What do you mean? Or what does it tells us? Napakibasa nga, energy, Ken?
Energy destroyed during a process. It can only change forms.
So it only tells us that energy is what? Just there. It's just there. Hindi yan nababawasan. Hindi yan nadadagdagan. Diba? Andyan lang siya. Okay? Nagbabago lang yung form. And the best way to explain this is through the what? The static and dynamic forms of energy during an interaction. Tama ba? From static, nung nagkaroon ng interaction, nagkaroon ng dynamic forms, which actually came from where? Doon din sa static forms of energy. Diba? transformation lang yung nangyayari. So what would be the benefit of having knowledge in the first law of thermodynamics? Ano yung importance nito? Sa engineering system, for example. Sa inyo as engineering, future engineers. Ano yung importance? Importance would be sa energy, 1 P K Sean. Diba? Energy, you'll be able to quantify particularly, the changes in energy. Importante yan, di ba, sa engineering? Paano mo maka-quantify correctly yung changes sa energy kung di mo alam ang first law? Kung alam mo na, ay, energy, nauubos ng nauubos, di ba? If you have that thought in mind, you won't be able to correctly quantify, di ba, energy changes sa engineering systems, di ba? But because you have the knowledge of the first law, tama yung magiging approach mo. As an engineer, since you know that energy is just there, nandiyan lang yung energy, and you're an engineer, perhaps you can develop or build a device that can harness the energy and be utilized, diba, for the benefit of the society or the community. Okay? So now we proceed to the what? To the calculation part. Kasi nga, first law of thermodynamics is what? Used in the quantification of energy during a thermodynamic process. Okay? If you're able to quantify changes in the static forms of energy, you'll be able to quantify what? The dynamic forms of energy. So, ang talagang directly na quantify natin dito is what? Yung static forms of energy. For example, yung change ng temperature. Diba, change ng temperature is change ng Ke ng molecule, change ng ng internal energy. Diba? Change ng static form of energy. How do you calculate for the heat transfer? Usually, you have the famous equation, Q is equal to MC delta T. You need first to get the delta T, diba? Tama? For you to be able to quantify Q. Understood? So, in thermodynamics, change is very important. So that's how you really apply the first law of thermodynamics. Yeah. So take a look at the equations that we have here. Still remember the total energy E? Diba, the total energy E is equal to what? Yung, ano tong unit to? Microscopic forms of energy, whereas these are the macroscopic forms of energy. Kung magbabago yung mga macro and microscopic forms of energy, magbabago rin siyempre si total energy. Naintindihan? However, for most of the systems that we're going to be considering, they are usually what? Stationary. Pag sinabing stationary, the delta PE and the delta KE is what? Equal to 0. Ibig sabihin, hindi nagbabago yung KE and PE as a whole. Ang nagbabago lang yung internal energy, which is the micro one. Diba? Yung mga macro, hindi talaga nagbabago. Bigay tayo ng example. Yung thermodynamic device natin, yung air conditioner dyan. Nag-undergone ba yan ang thermodynamic process kapag naka-on? Yes. Diba? So, ang nagbabago lang is yung internal energy ng system. Ang system mo talaga dyan, yung refrigerant. Okay? Tama? Now, nagbabago ba yung PE niya as a whole? Yung elevation niya, nagbabago? Hindi. Gumagalaw ba siya as a whole? Hindi rin. KE and PE as a whole, hindi nagbabago. Ano lang ang nagbabago? KE and PE of the particles. Especially pag nag-undergo ng change in phase yan. May change na yan sa potential energy. Nagbabago rin ng temperature niyan. Change saan? Kinetic energy ng molecules. So it's just the what? The change in internal energy such that delta E can just be equated to what? Delta U. For station analysis. Heat engines. Ano yung pinaka-system natin doon? Ano yung substance doon? Yung fuel, di ba? Yes sir, doon, nagbabago yung KE, di ba? Tsaka PE as a whole. Kapag umaandar, di ba? Pag nag-accelerate, nagbabago as a whole, di ba? But then again, bago nagkaroon ng change sa KE and PE as a whole, bago nangyari yun, saan muna yung change? Doon sa internal, internal structure ng fuel. Di ba nagkaroon muna ng combustion? Ibig sabihin, nagkaroon muna ng change sa internal energy bago nagkaroon ng manifestation sa changes ng PE and KE as a whole. So basically, we can still equate delta E saan? Delta U. Kasi yung corresponding changes doon sa delta U when it combusts, di ba? Diba? During the combustion of fuel in the car engine, yung combustion na yan ang ginagamit to what? To change the KE. Or maybe to change the PE. Do you understand? Still, it can be considered as what? A stationary system. This is the KE and PE as a whole dominant. Okay? Okay, so we say that delta E is what? Just equal to delta U for a stationary system. Ano nga ulit ito? Internal energy change. Internal energy is what? A static form of energy. Bakit nagkakaroon ng change sa static form of energy? Dahil sa dynamic form of energy. If we go back to our thermodynamic processes earlier, tingnan natin. Piliin natin yung isobaric process, for example. Isobaric, Isobaric. Para magkaroon ng change sa temperature, kailangan meron munang heat transfer. Di ba yung temperature has something to do with the KE molecules, which is part of the internal energy? Tama? So, ibig sabihin, meron kang internal energy initial dito. Initial. Para magbago yung internal energy mo, para magkaroon ng delta U, kailangan magkaroon ng heat transfer. Ibig sabihin, may involvement si dynamic forms of energy. After heat transfer, ano mangyayari sa temperature? Tataas. May delta U. Tama? Even more, because of the movement of the piston, nagkaroon ng work done. Naintindihan? Kaya pwede natin i-equate si change sa internal energy doon sa pumasok at lumabas na energy, which is your what? The dynamic forms Q and work. Okay? Meron pang isang dynamic form of energy na alala niya, yung mass transfer or matter transfer. Pero di ba closed system tayo? Kaya lahat yan, mga closed system yan actually. Pag nag-leak yung refrigerant mo dyan, di ba? Ano yan? Hindi yan magpa-function efficiently. Do you understand? So we have this equation now for a closed system that for you to account for the change in the static form of energy, you have to consider the energy that is what? Going in and going out. So as you can see here, Q and W are what? The dynamic forms of energy. Now, yung sign ng delta U natin, pag sinabing sign, malalaman mo kung tumataas or bumababa, di ba? Malamang kung ang temperature tumaas, ano nangyari sa KE ng molecules? tumaas din. So the delta U will be what? Positive or negative? It will be positive. Kung ang temperature bumaba, syempre, ang delta U will be negative. So depende yung kung anong process. Even more kung heating or cooling yung nangyari. Expansion or compression. Tama? Alam natin na kapag ang Q ay pumasok sa system, is that positive or negative? Positive. Pag lumabas ang Q mo ay negative. Paano naman sa work? Ano yung sign convention? Because this is the general equation. You're not inserting here, or you're not applying here yet the signs. Because you have to consider the sign convention for the dynamic forms of energy. In particular, alam natin sa Q, positive yan kapag yung heat pumasok sa system. Pag lumabas, negative. Pero sa work, ano? Ang ginamit na convention dito, kapag ang work ginawa ng system, in that case, expansion, tama? Si system yung nag-expand, ideal gas, siya yung gumawa. And every time na gumagawa ng work si system, naglalabas siya ng energy. Do you agree? So kung maglalabas ka ng energy, ano yung sign ng energy na nilabas mo? Or yung work na ginawa mo? Negative. Okay? Kapag compression naman, nag-apply ka na work done doon sa system, si system yung naka-accept ng ng work, ng energy. Ibig sabihin, yung surrounding yung gumawa. Nag-absorb siya na, tumanggap siya ng energy. So kung tumanggap siya ng energy, positive. So we have positive work done onto the system. Question? So we're now going to apply this general equation doon sa thermodynamic processes natin. Okay? So let's apply first your isothermal process. Let's use a different color. Delta U is equal to what? Q plus W. Now, i-recall natin yung condition sa isothermal process. Isothermal process, meron bang heat na sinupply during the process? Yes. Meron bang work na nagawa during the process? Or even after the process? Meron din. So, included si Q and W. Yung change sa internal energy, nagbago, yes, especially during the process. But remember, this is an ideal gas. Saan lang yung change na ina-account natin? Kinetic energy ng particles. It has something to do with what? With the temperature. Kung ang temperature hindi nagbabago, ang delta U mo would be what? Zero. So delta U is, therefore, Q is just equal to the negative of. Di ba yan yung ano natin kanina? Yung sinabi natin na lahat ng heat na pumapasok, ginagawa for work. Or kino-convert lahat for work. Naalala ka? Yung nga lang, negative. Magkaiba sila ng sign. Kasi yung heat, pumapasok, yung work, ginagawa ng system. So pag ginagawa ng system, negative yung work. Understood? Isobaric. Regardless of the mechanism, whether expansion or compression, ito pa rin yung equation mo. Ito pa rin, hindi mo ba? Yan yun. Kung compression na siya, anong mangyayari dito? Positive, di ba? Now, yung heat may re-release na palabas, di ba? Anong mangyayari dito? Magiging negative. So, ganun pa rin. Diba? Hindi siya, hindi magbabago yung general equation. Okay? Delta U is equal to what? Q plus W. Okay? So, dito, yung delta U mo, hindi na zero. Now, since meron ka rin Q and work, included siya sa equation. So, ito, for an isothermal process, this is for an isobaric process. Okay. Whether expansion or compression, i-account natin yung sign ng Q and M. Sa isochoric, naalala niyo siguro sa physics to, diba? Tinakal dito sa physics, Q plus W. Ano yung wala dito? Walang work done. Expansion or pertaining to the, we're looking at for the expansion work. So, maraming types of work. But in terms of expansion, this is 0. So delta U is just equal to the, diba, yung heat na pinapasok, ginagamit lang to increase the temperature. Kaya yung delta U nagbaba. And last but not the least, for an adiabatic process, delta U, start with the general equation, Q plus W. Q is equal to 0, so delta U is just equal to the work done. Okay? Adiabatic. So lagi ako ganitong discuss, no? Medyo, di ba sinasabi, sir, medyo, kasi para bang puro lecture ako, alam mo lang parang participation. Medyo iba sinasabi, nakaka-overwhelm daw. Kasi, di ba, ang dami nang pumapasok eh. Ang dami ng information. That's why maganda merong audio recording or video para you can go back and understand. So, for the 5 minutes remaining, ano pang pwede natin isama? Sige, let's see if meron pa akong nakalimutan sabihin na nasa exam. Okay, so for next meeting, we'll talk about the formulas for heat and work. Siyempre, hindi naman, for a particular process, hindi naman basta ibibigay yung value ng alin, ng Q, di ba, or ng W, for you to get the delta U. Kailangan, so muna yung alin, yung values ng work and Q for a particular process. So, we'll consider first formulas for Q, and from there, formulas naman na work. So remember the heat capacity, di ba? C. Doon natin madederive yung formula for Q. The Q is equal to MC delta T. So work naman, we already had the formula for work, di ba? Negative P, change in volume, but there's actually a rooted equation for that. Hindi yun yung pinaka-starting equation natin. So, mag-start tayo dun sa pinaka-rooted equation, then you'll see why yung negative P delta V yung ginagamit natin. But why is there a negative there again? Bakit may negative dun sa P? Depends on the reference. No? May mga references na yung pressure positive, P delta V yung ginagamit, walang negative. Again, it depends on the, kailangan lang consistent ako throughout the process. In our case, bakit may negative doon? Kasi, for work to be done, diba? Kailangan ma-overcome yung external pressure. So, we're actually pertaining to the external pressure, diba? Not yung pressure exerted by the system. So that's not the general, but the semi-general equation for work. Work is equal to negative PV. Okay? So, sana okay yung video. Especially dun sa earlier classes.